So here p of x is a polynomial x, polynomial. So this relation is a, so you can write f of x also, there is no problem. So p of x is given as a 3x plus 1. Now it is asked to test whether x equal to minus 1 by 3, x equal to minus 1 by 3 is a zeros of the polynomial. Zeros means what? If we place these values in place of x equal to, if I put minus 1 by 3, then we have to see that the right hand side, the value calculation part, if it becomes 0, then we say this is a zeros of the, that means this makes the polynomial 0. This value makes the polynomial to 0, that is called zeros of the polynomial. This is called zeros of the polynomial. So here let us put these values, 3 into x in place of 3 plus 1. Now numerator denominator get cancelled, 3 and 3, 3 by 3 is 1, so this became minus 1 and plus 1, so it makes the things zeros. So that means this x equal to minus 1 by 3 value is a zeros of the polynomial. We'll move to the next equation. P of x is 5x minus pi, and it's asked to test at the value 4 by 5, x equal to 4 by 5. So let us put p, you have to write 4 by 5. So in place of x we will put 4 by 5 minus pi. So 5 and 5 get cancelled, 1. So this value became 4 minus pi. Okay, and you know that value of pi is 3.14. So basically this becomes a non-zero. This is not a zero values after calculation. So that means this x equal to 4 by 5, this is a not a zeros of the polynomials. Okay, we'll move to the next function. P of x is given as a x square minus 1, x square minus 1. Here it is asked to test whether x equal to 1 is a zeros of the polynomial, and also x equal to minus 1. Both the values we need to test it. So let us first test with x equal to 1. So what we write? P of 1, in place of x square we'll put 1 1 zeros. So this is a zeros of the polynomial. Okay, then also we'll test with minus 1 whole in this equation, minus 1 whole square minus 1 whole square is 1, 1 minus 1 is zeros. So that means this is also zeros of the polynomials. So if you see answer our first one, this one was zeros of the polynomials. X equal to 4 by 5, it couldn't make this is here. So this was not able to make the value 0. So this is not a zeros of the polynomial. This has made 0 to the equation, and x minus 1 also makes the equation 0. So this x equal to minus 1 is also zeros of the polynomial. Here the next function is x plus 1 into x minus 2. Okay, and where it is asked to test for value x equal to minus 1 and then x equal to 2 as well. Okay, so we'll test separately. So x okay, let us put minus 1 here, and x, if we replace x with a minus 1, we get the expression here. and in this calculation if you see that -1 +1, this is becomes 0, so whatever value it is, so it will end up with 0 only. So that means this x equal to 1, x equal to -1, that makes the equation 0. So this is a zeros of the polynomial. Okay, now let us test second point, x equal to 2. So 2 plus 1, this is the equation, so 2 plus 1, and here 2 minus 2. In this case you see this is the second term, because 2 minus 2 0, so this product will be 0 always. So in that case x equal to 2 also made the equation 0, so x equal to 2 also a zeros of the polynomial. So both -1 is zeros of the polynomial, 2 is also zeros of the polynomials. Next function is p of x is x square, and it is asked to test at x equal to 0. So if we put 0 square 0, so that means x equal to 0 has made the given polynomials to 0. Okay, so that means this is x equal to 0 is a zeros of the polynomial. Okay, so here p of x is giving lx plus m and x equal to minus m by l. That means it is asked to test in x equal to minus m by l what will be the value of this p of x, and if it is a 0, that means this is called as a zeros of the polynomial. So let us replace it here, and so how to replace in place of variable x. So here in place of x we will write minus m by l plus m. So l numerator denominator get cancelled, so this became minus m and it became plus m, so it becomes 0. So that means x equal to minus m by l makes the polynomial 0, so that is a zeros of the polynomial. Here function is given as a p of x equal to 3x square minus 1. We need to test x equal to -1 by root 3 and 2 by root 3 for whether these two are zeros of the polynomial or not. To test that, what we need to do, that replace x value with the given values and see that what it ends up. If it is ends up with a 0, then these will be called as a zeros of the polynomial. So now let us replace it, minus 1 by root 3. So 3x is minus 1 by root 3 square minus 1. So if we simplify it, let's see, minus 1 by root 3, if that means twice. If you are confusing, so minus whole square means 2 times. If you or let us write this way if you are not very clear. So we will multiply 1 by root 3 twice, so minus and minus become plus, and root 3 and root 3 become 3, 1 and 1 1, so numerator 1, denominator become 3. So 3 into 1 by 3 minus 1, 3 into 1 by 3, 3 3 get cancelled, so it become 1, 1 minus 1, so it becomes 0. So that means this, if you replace x equal to 1 by 3 in this equation, you get zeros here. So that means we can say that this is zeros of the polynomial. Same way, let us test for 2 by root 3. So let us replace in the equation 2 by root 3 whole square minus 1, 3 into 2 by root 3. If you multiply twice, you can calculate here. If you confuse, write it separately and do the clear calculation. Okay, 2 2 4, root 3 is 3. So 3 into 4 by 3 minus 1. 3 3 1 1. So 4 minus 1 is 3, which is not equal to 0. That means x equal to 2 by root 3 is not a zeros of the polynomial because it couldn't make the value zeros. So that is why x equal to 2 by root 3 is a not a zeros of the polynomial, whereas x equal to minus 1 by root 3 is a zeros of the polynomial.